This video continues the lesson about Chapter 5.3 and the use of square roots in solving quadratic equations. And in this case, we're going to talk about how to apply that technique in a word problem. Calculations about falling objects come up in physics classes. They will also probably come up in some standardized tests. So it's useful to know and be able to work with this very widely used equation here that essentially is saying that the final height of something you drop, that falling object, is equal to, it turns out, negative 16 times the amount of time squared that it falls added to whatever height it started from. So let's say it starts at the top of a building that's 300 feet high. You add that to negative 16 times, let's say it falls for 5 seconds, or in other words, that's 25. You work that all out, and you're going to find out how far it's fallen after those seconds have passed. Now, let's look at a specific example here, and here's the word problem. So I'm going to have you hit the pause button and read example 4 to yourselves, and then we're going to talk about how to work this through. Okay, I'm going to assume that you've done that, that you've read this story about the stuntman. Now, as the textbook suggests, first of all, you could solve this by making a table. You would simply put in different values for t, and you would see how far it had fallen. So, for example, if you put 0 into this equation, 0 squared is 0, so that's nothing here. And so you're going to have plus 100, or in other words, the original height, which is 100 feet. After 1 second, 1 squared is 1. Negative 16 times 1 is negative 16. Negative 16 added to 100 is 84. You can keep going and fill this out, and what you'll find is that something happens between second 2 and second 3. It goes from a positive height of 36 feet to negative 44 feet. In other words, if it were possible for the thing to keep falling, the thing, it's a stuntman, for the person to keep falling all the way to 3 seconds, he would be 44 feet through the floor. But he's going to hit that cushion well before that. That cushion is 9 feet high. Of course, 9 feet is somewhere between 36 and negative 44. So he's going to fall somewhere between 2 and 3 seconds. And that's what it says here. He's going to take between 2 and 3 seconds to fall. But another and more accurate way to answer the question is to solve it. So writing that equation down and then plugging in a value, the height he's eventually going to reach is going to be 9 feet. That's the height of the cushion. So he's going to fall from 100 feet down to 9 feet. How long is this going to take? Move the 100 over. And it's going to be negative 16t squared equals negative 91. Now move the negative 16 over by dividing negative 1 by negative 16. And now that becomes a positive value, 91 over 16. Now, because we now know how to work with fractions and taking the square roots of fractions, we could do this without a calculator. But it makes most sense if you have the calculator handy to go ahead and do that. One way is to say that t is going to be equal to 91 over 16, the square root of that. Now, remember, I'd been talking up until now about the importance of saying that that really ought to be plus or minus, but there's no such thing as negative time. So in this case, it really is positive square root of 91 over 16, and if you put that into a calculator, you'll find that's roughly 2.4 seconds. So that's how long it takes the stuntman to fall. And that's it for this video lesson. Just wanted to make sure that I talked that through for you, and I look forward to seeing you in class.